In this video, we're going to talk a little bit more in detail about format string vulnerabilities. So, as a reminder, the format string vulnerability occurs when you allow a user to pass information into one of the variable argument functions, the most common one being printf. There's a whole family of functions related to printf. So use of any of those functions will cause this problem to occur. So what I've done here is I have a very simple program which I've written. And in this simple program, we have a simple function called vulnerable that takes a single character string as a parameter. It allocates a buffer of 256 bytes, which will store 255 characters plus the null character at the end. And in this case, the programmer is probably thinking they're doing a good job because they use strncpy instead of strcpy. As we've seen before, strcpy is dangerous because you can overrun a buffer. Here, strncpy has been used. So I'm copying from param into my buffer, and at most, I am copying the size of my buffer -1. Again, I need the extra byte for the null character, which, by the way, is another common mistake. Sometimes people will use strncpy and forget they need to subtract 1. Once this is done, I call printf, and then I return the number 42. Looking at my main program, I have my argument that's passed in on the command line. And if you pass in an argument, I will pass it on to vulnerable. Otherwise, I'm just going to exit. It doesn't crash if you didn't give it an argument. If I run this particular program, it will print out whatever I typed. So if I change to this directory and I run my program, if I run it with no arguments, it just exits. And if I run it and I give it hi, it prints hi. Or if I have a longer string, that also works. What if I give it some strange parameters? Let's say something like this, %x, %x. Now it's going to print some values to the screen. And you might say, well, what are those values? Those are values that it was expecting to be passed in later parameters. And that is a problem that we can run into with printf. So going back to our program, notice that we have printf being called, and printf can be used in this very simple way where you give it a parameter and it prints it out, or the more full-featured way where you give it a format string and then a list of arguments to print out. If the programmer had simply typed printf and then quote %s and quote comma buff, it would have fixed this issue. All right, so let's have a look at this program. If we open it up in Immunity Debugger, we will see our program here, and we will see how we can use this %x to generate some things which would crash this program. And before we do that, we should also look at another parameter, and that parameter is %n. So I'll give you a valid use of %n. I can say hi, 1, 2, 3, 4%n. Now, the reason that it crashed is that this %n method expects a pointer, a memory location, to where it can store the number of characters that it has put out into the n string. Here's what this means. I can use %x to get parameters. Where are these parameters coming from? Parameters being passed to different functions are stored on the stack. So every time I have a %x in my string, it's going to try and pop some of those variables off of the stack. If I add a couple more, I get a certain pattern. Now, it might not be completely obvious exactly what's happened here because of the way that I did this. You might not be familiar with the ASCII codes for %x. But what if I create a call with a marker at the beginning of my string? And the marker I will use is 4 lowercase a's, which have a hex ASCII value of 61. Now, when I print this, notice what's happened here. I have a few values that are printed out, then 616161. That's the start of this format string. And then 7825, the 78 is the X, 25 is percent, and that's repeated. These are reversed because of little endedness, which is why the 78 comes before the 25. And I can continue this pattern. I can use this to pop some of those variables off of the stack until I get to the variables that are interesting to me or the start of some shellcode. So I can use that to determine what addresses I want to have. Again, I'm popping things off of the stack. And I can use the %n in order to print out the number of characters I have printed so far, which I can, of course, control. And if I can control the number of characters that have been printed, and that value is going to be stored into a memory location, which I also control, I can have a lot of fun if I'm an attacker. We're going to take a brief break here. And when we come back, we're going to look at this program in Immunity and see how we can go about finding the appropriate inputs in order to exploit this vulnerability.